You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Manufacturing and logistics are industries built on precision, efficiency, and reliability, making them prime candidates for transformation through artificial intelligence. At their core, these sectors deal with producing goods and ensuring they move smoothly across global supply chains to reach customers. The complexity is immense. Factories juggle production schedules, equipment maintenance, and energy costs, while logistics firms manage warehouses, fleets of vehicles, and international shipping regulations. AI is now deeply embedded in these processes, analyzing vast amounts of data to uncover inefficiencies, predict problems, and recommend solutions. From ensuring machines do not break down unexpectedly, to charting the fastest delivery routes, to reducing waste in production, AI systems provide insights at a speed and scale beyond human capability. In this episode, we will explore how AI is reshaping both factory floors and delivery networks, making global production systems more adaptive, resilient, and intelligent. Early automation in manufacturing set the stage for AI's eventual rise. Decades ago, factories began incorporating robotics and process control systems that could handle repetitive tasks more consistently than human workers. Early robots were often confined to simple actions like welding or painting and operated in cages to keep humans safe. Process control systems monitored machines and adjusted parameters like temperature or pressure to maintain efficiency. While groundbreaking, these systems were rigid and lacked adaptability. They could not learn from data or respond to unexpected changes. AI builds upon this foundation by adding flexibility and intelligence, allowing machines to not only follow programmed instructions but also optimize themselves over time. This progression from basic automation to adaptive intelligence demonstrates how manufacturing has evolved from mechanical precision to dynamic learning systems that adjust to changing conditions. Predictive maintenance is one of the clearest examples of AI delivering immediate value in manufacturing. Traditionally, maintenance was either scheduled at fixed intervals or performed only after equipment broke down, both of which were costly approaches. AI changes this by analyzing data from sensors embedded in machines, measuring vibration, heat, pressure, and more to forecast when a failure is likely to occur. For example, if a factory robot shows subtle changes in motor vibration, AI can flag the issue before it leads to a breakdown. This allows repairs to be scheduled during planned downtime rather than during critical production runs. The result is fewer disruptions, longer equipment lifespans, and significant cost savings. Predictive maintenance illustrates how AI helps organizations move from reactive firefighting to proactive planning, ensuring production lines remain smooth and dependable. Quality control has also been revolutionized through computer vision systems powered by AI. Traditionally, human inspectors checked products for defects, a process prone to fatigue and inconsistency. Now, high-resolution cameras paired with AI algorithms can examine thousands of items per minute, detecting flaws too small or subtle for the human eye. For instance, AI can identify tiny cracks in car parts, irregular stitching in textiles, or misaligned labels on packaging. These systems provide consistency, accuracy, and speed that dramatically reduce waste and rework. Moreover, AI can track defect patterns, helping manufacturers identify root causes and improve processes upstream. Quality control is no longer just about catching mistakes at the end, but about preventing them from recurring, turning inspection into a continuous improvement engine that strengthens the entire production cycle. Process optimization is another domain where AI plays a central role. Manufacturing involves countless interconnected steps, from raw material handling to final assembly. Inefficiencies in one stage can ripple through the entire system. AI analyzes workflows, identifying bottlenecks and recommending adjustments that improve throughput. For example, it might suggest reordering tasks on an assembly line, adjusting machine speeds, or reallocating resources to balance workloads. These insights are not static but dynamic, adapting to real-time changes such as supply shortages or sudden demand spikes. By continuously learning and adjusting, AI ensures processes remain efficient under shifting conditions. This adaptability mirrors the broader shift in manufacturing toward flexibility and customization, moving away from rigid mass production toward systems that can pivot quickly to meet new market demands. Supply chain visibility has historically been one of the greatest challenges in manufacturing and logistics. Global supply chains involve thousands of suppliers, carriers, and intermediaries, making it difficult to track materials and products in real time. AI addresses this by integrating data from sensors, shipping records, and even external sources like weather forecasts to provide a comprehensive picture of where goods are and when they will arrive. For example, an AI system can anticipate delays at a port due to storms and reroute shipments accordingly. This visibility reduces uncertainty, enabling companies to plan production schedules more accurately and respond quickly to disruptions. By making supply chains more transparent and predictable, AI enhances resilience in systems that underpin the global economy. Warehouse automation is another area where AI delivers transformative efficiency. Modern warehouses increasingly rely on robots guided by AI to manage inventory, pick items, and fulfill orders. These systems work tirelessly, navigating complex layouts and ensuring products are located and packed with speed and accuracy. AI also optimizes storage, arranging goods in ways that minimize retrieval time and maximize space. For instance, frequently ordered items may be placed closer to packing stations, reducing travel time for robots. The result is faster order fulfillment, fewer errors, and reduced labor costs. In many ways, AI-powered warehouses are becoming the backbone of e-commerce, where customer expectations for rapid delivery are constantly rising. Route optimization highlights AI's value in logistics, where transportation costs and delivery times are critical. Traditional route planning often relied on static maps and fixed schedules, but AI continuously analyzes real-time data such as traffic conditions, weather, and delivery priorities to calculate the most efficient paths. For example, a logistics company may use AI to reroute trucks around traffic jams, ensuring packages arrive on time. In large fleets, these optimizations can save millions in fuel costs and reduce emissions. For customers, it means faster and more reliable deliveries. Route optimization illustrates AI's ability to translate raw data into concrete actions that improve both efficiency and sustainability across global transportation networks. Demand forecasting in logistics complements manufacturing by predicting how many products will need to be shipped, when, and where. AI analyzes sales data, seasonal trends, and external signals like promotions or economic shifts to anticipate shipping volumes. For instance, AI might predict increased demand for electronics during holiday seasons and recommend adjusting warehouse capacity and transportation resources in advance. Accurate forecasting helps prevent bottlenecks, reduces delays, and ensures that goods move smoothly through the supply chain. It also minimizes wasted capacity, ensuring resources are allocated efficiently. By transforming uncertainty into predictability, demand forecasting makes logistics systems more agile and responsive to consumer needs. Workforce scheduling is another area where AI has made significant strides, balancing labor needs with employee availability. Factories and warehouses require precise staffing levels to maintain productivity without overspending on labor costs. AI systems analyze production schedules, order volumes, and employee preferences to create optimized rosters. For example, during peak seasons, AI may predict higher labor demand and suggest staggered shifts to cover workload surges. This ensures that operations run smoothly while respecting worker well-being. Better scheduling reduces turnover, improves morale, and enhances overall efficiency. By managing one of the most variable aspects of operations, human labor, AI ensures that people and machines work together harmoniously in dynamic environments. Energy optimization in factories demonstrates how AI contributes not only to efficiency, but also to sustainability. Manufacturing facilities consume vast amounts of energy, and even small inefficiencies can lead to enormous costs. AI monitors equipment usage, production schedules, and energy prices to identify savings opportunities. For instance, it might shift energy-intensive processes to off-peak hours, or adjust machine operations to reduce waste. Over time, these adjustments significantly cut costs and lower carbon emissions. In an era of growing environmental concern, energy optimization provides both financial and reputational benefits, showing how AI can align industrial goals with broader sustainability objectives. Digital twins represent one of the most exciting innovations in manufacturing and logistics. A digital twin is a virtual model that mirrors a physical system, whether it's a machine, a factory, or an entire supply chain. By simulating real-world conditions, digital twins allow businesses to test scenarios without disrupting actual operations. For example, a manufacturer might use a digital twin to experiment with new assembly line configurations, while a logistics firm might simulate how port delays would affect shipments. AI enhances these models by processing vast amounts of data to ensure accuracy and provide actionable insights. Digital twins create a bridge between the physical and digital worlds, enabling continuous improvement and innovation. Autonomous vehicles are increasingly becoming part of logistics operations, including self-driving trucks, drones, and even autonomous ships. These vehicles use AI to navigate, avoid obstacles, and optimize routes with minimal human intervention. For example, drones can deliver packages in urban areas more quickly than traditional couriers, while autonomous trucks can reduce driver fatigue on long-haul routes. Ships equipped with AI navigation systems can plot safer, more efficient courses across oceans. While regulatory and safety hurdles remain, the potential benefits are enormous: reduced costs, faster deliveries, and greater safety. Autonomous vehicles showcase how AI is redefining transportation in logistics, creating possibilities that once belonged to science fiction but are rapidly becoming reality. Risk management in supply chains is a complex task, as disruptions can stem from natural disasters, political instability, or supplier failures. AI improves this process by analyzing diverse datasets to identify vulnerabilities and predict potential issues. For instance, I might detect early signs of financial distress in a supplier, or predict delays due to severe weather events. By flagging risks early, companies can develop contingency plans, such as sourcing from alternative suppliers or adjusting inventory levels. This proactive approach reduces the impact of disruptions and maintains continuity. In a global economy where supply chains are increasingly interconnected, AI's role in risk management is critical to resilience and reliability. Global trade and logistics add another layer of complexity, involving customs regulations, tariffs, and cross-border documentation. AI assists by automating compliance checks, ensuring shipments meet international requirements before they arrive at borders. For example, I can scan shipping documents for inconsistencies that might delay customs clearance, reducing costly holdups. It also helps optimize routing for international shipments, balancing speed, cost, and regulatory compliance. In a world where trade tensions and regulations are constantly evolving, AI provides agility and confidence to businesses operating globally. This application underscores AI's role not just in efficiency, but also in navigating the legal and regulatory frameworks that shape global commerce. Challenges in manufacturing AI remind us that adoption is not without obstacles. Implementing AI systems often requires significant upfront investment in infrastructure, such as sensors, connectivity, and data platforms. Integration with legacy systems can be complex, as older equipment may not be designed for data-driven optimization. Workforce adaptation is another hurdle, as employees must learn to work alongside intelligent systems and sometimes fear being displaced. Addressing these challenges requires careful planning, strong training programs, and clear communication about AI's role as a partner rather than a replacement. While the journey can be difficult, the rewards in efficiency, quality, and competitiveness make AI adoption increasingly necessary. Recognizing and managing these barriers ensures that manufacturing AI fulfills its potential without leaving workers or companies behind. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Robotics in manufacturing has evolved from isolated machines performing repetitive tasks to intelligent systems working seamlessly with humans. Industrial robots now assemble cars, weld parts, and handle dangerous materials with a level of speed and consistency that humans cannot match. What makes them powerful is their ability to operate continuously, reducing downtime and ensuring predictable output. With AI integration, these robots are no longer limited to rigid programming but can adapt to variations in materials or tasks, learning from data and improving performance over time. This evolution allows factories to be both efficient and flexible, producing goods at scale while maintaining high quality. Robots remain a symbol of industrial progress, but when paired with AI, they represent something more: the shift from mechanized repetition to intelligent collaboration, where machines contribute not just muscle, but also adaptability and insight. Collaborative robots, often called cobots, are designed specifically to work safely alongside human workers. Unlike traditional robots confined behind safety barriers, cobots use sensors and AI algorithms to detect human presence and adjust their movements accordingly. For example, in electronics assembly, cobots might hold a component steady while a human technician performs delicate wiring. This partnership combines human dexterity and judgment with robotic precision and endurance. Cobots also reduce the need for extensive safety infrastructure, making automation more accessible for smaller businesses. Beyond efficiency, cobots change workplace culture, shifting the perception of robots from competitors to teammates. By designing systems that prioritize cooperation, manufacturers demonstrate how AI can enhance human labor rather than replace it, reinforcing the principle that technology should augment human potential. Additive manufacturing, commonly known as 3D printing, has opened new opportunities for production, and AI plays a critical role in optimizing these processes. 3D printing allows manufacturers to create complex parts layer by layer, reducing waste and enabling customization. AI enhances this by monitoring print quality in real time, adjusting parameters like temperature or material flow to prevent defects. It can also simulate different design options, identifying the most efficient configurations before production begins. For example, I might suggest structural adjustments that maintain strength while reducing material use. This combination of AI and additive manufacturing supports innovation, allowing companies to prototype rapidly and move products to market faster. It also contributes to sustainability as less material is wasted compared to traditional manufacturing. Together, AI and 3D printing represent the future of flexible, adaptive production. Inventory optimization is a constant challenge in manufacturing and logistics, requiring balance between meeting demand and minimizing excess stock. AI systems address this by analyzing demand signals, supplier performance, and sales trends to determine the right stock levels. For instance, if AI predicts increased demand for certain electronics due to seasonal trends, it can recommend scaling up production and storage while reducing stock in less popular items. These models adapt as conditions change, avoiding both shortages and overstock situations. Optimized inventory ensures that companies use resources efficiently, reduce costs, and deliver products on time. For consumers, it means fewer delays and better availability of desired goods. Inventory optimization shows how AI supports the delicate balance between efficiency and reliability in supply chains, keeping businesses lean without sacrificing responsiveness. Cold chain logistics is one of the most demanding areas of transportation, as it involves moving goods that must remain within strict temperature ranges, such as vaccines, food, or pharmaceuticals. AI enhances this process by continuously monitoring temperature sensors, humidity levels, and transit conditions, ensuring goods remain safe throughout the journey. For example, if a shipment of medicine experiences a temperature spike, AI can trigger alerts and reroute it to prevent spoilage. Predictive models can also forecast risks, such as delays that might expose shipments to unsafe conditions. By reducing losses and ensuring safety, AI strengthens trust in critical supply chains. Cold chain logistics illustrates how intelligence safeguards not just products but also public health and safety, ensuring that vital goods arrive in usable condition regardless of challenges along the route. Ports and airports are critical hubs in global trade, and AI is revolutionizing their operations. These facilities handle massive volumes of goods daily, requiring precise scheduling and coordination. AI systems analyze data on vessel arrivals, cargo loads, and weather conditions to optimize scheduling, reducing bottlenecks and delays. For example, AI might predict congestion at a port and adjust docking schedules accordingly, improving turnaround times for ships. At airports, AI helps manage cargo routing, customs clearance, and ground crew assignments. These efficiencies not only save money, but also enhance the reliability of global supply chains. In a world where delays can ripple across continents, AI's role in optimizing hub operations is essential. By bringing order to complex, high-volume environments, AI ensures that global commerce continues to flow smoothly. Autonomous mobile robots are increasingly deployed in warehouses to handle material transport and order fulfillment. Unlike fixed industrial robots, these small AI-powered machines can navigate dynamic environments, avoiding obstacles and coordinating with other robots and humans. For example, in an e-commerce warehouse, autonomous robots carry shelves of products to human workers for picking, drastically reducing walking time and increasing efficiency. These systems rely on AI for mapping, path planning, and real-time adjustments, enabling them to operate safely in crowded environments. The result is faster, more accurate fulfillment at lower labor costs. Autonomous mobile robots embody the principle of flexibility, scaling up or down depending on demand. They highlight how AI-driven machines are reshaping logistics from the inside, making warehouses smarter, safer, and more productive. Real-time analytics in logistics has become a crucial capability, providing actionable insights through dashboards that track supply chain performance. AI systems aggregate data from sensors, shipments, and customer orders to present managers with clear, timely information. For instance, a logistics dashboard might show delivery delays in a specific region, allowing companies to reroute shipments before customers are affected. Real-time insights also support proactive problem-solving, reducing the need for costly firefighting after disruptions occur. By visualizing supply chain health in an accessible way, AI empowers decision-makers to act with speed and confidence. Real-time analytics ensures that logistics is no longer reactive but anticipatory, aligning with the broader theme of AI as a tool for foresight rather than hindsight in global operations. Sustainability in manufacturing has gained new urgency, and AI is playing a vital role in reducing environmental impact. Factories contribute significantly to emissions and waste, but intelligent systems can optimize processes to minimize these effects. AI might analyze production lines to reduce material waste, optimize machine energy use, or design products for easier recycling. Logistics also benefits, with AI recommending fuel-efficient routes or helping companies shift to greener transportation modes. By quantifying and reducing carbon footprints, AI aligns manufacturing and logistics with growing societal demands for environmental responsibility. This not only improves reputation but also meets regulatory requirements and reduces long-term costs. Sustainability through AI reflects how intelligence can harmonize profitability with responsibility, shaping industries that are both competitive and conscientious. Fraud and theft detection in logistics is another critical application, as stolen or diverted goods represent major losses. AI systems monitor shipment data, scanning for irregular patterns that may signal tampering or theft. For example, if a shipment deviates from its planned route without explanation, AI can raise an alert for investigation. Image recognition also plays a role, identifying unauthorized access in warehouses or transport vehicles. These safeguards protect not only company assets but also customer trust, as stolen or compromised goods can damage reputations. By detecting threats early, AI ensures logistics systems remain secure, reinforcing reliability in industries where trust and precision are paramount. Fraud detection shows how intelligence strengthens not just efficiency, but also integrity in global operations. Multimodal transportation optimization is a complex but essential challenge for global logistics. Goods often travel through a combination of trucks, trains, ships, and planes before reaching their destination. AI coordinates these modes by analyzing costs, timing, and environmental impact to recommend the most efficient routes. For instance, it may determine that shifting part of a shipment from air to rail saves money and reduces emissions without delaying delivery. By integrating data across different carriers and geographies, AI creates unified plans that minimize inefficiencies. This holistic approach ensures that logistics networks function as interconnected systems rather than isolated segments. Multimodal optimization highlights how AI brings clarity and coordination to the vast complexity of global trade. Disaster recovery in supply chains has become a priority as natural events like hurricanes, earthquakes, and pandemics disrupt global flows. AI supports resilience by predicting risks and modeling responses. For example, by analyzing weather forecasts, geopolitical trends, and supplier vulnerabilities, I can simulate potential disruptions and recommend contingency plans. If a storm threatens a key port, I might suggest preemptive rerouting of shipments or increased inventory in alternative locations. These preparations reduce downtime and financial losses, ensuring continuity even in crises. Disaster recovery through AI is not about eliminating risk, but about managing it intelligently, turning unpredictable events into manageable challenges. It underscores AI's role as a stabilizer in an increasingly volatile global environment. Human-machine collaboration in factories represents a new era of industrial work. AI systems now support humans by taking over repetitive tasks while leaving complex problem-solving and creative thinking to people. For example, an AI system might handle the precise assembly of components, while human workers oversee quality control and adjustments. This partnership enhances safety, reduces fatigue, and increases productivity. Importantly, it reframes automation not as a threat but as an ally, with workers focusing on tasks that require adaptability and judgment. Training programs are critical to this shift, ensuring employees understand how to work effectively with AI systems. Collaboration fosters a workplace where human skills and machine intelligence complement each other, creating factories that are not only more efficient but also more humane. Edge AI in logistics is a rapidly emerging trend, bringing intelligence closer to the devices and vehicles operating in the field. Instead of sending all data to centralized servers, Edge AI processes information locally, enabling faster decisions and reducing reliance on constant connectivity. For instance, a delivery truck equipped with Edge AI can analyze road conditions and adjust routes instantly without waiting for cloud instructions. Similarly, IoT devices in warehouses can detect issues and respond immediately, such as redirecting robots to avoid collisions. Edge AI enhances resilience as systems continue operating effectively even when network access is limited. By distributing intelligence across the network, Edge AI supports the speed and reliability demanded in modern logistics, pushing the boundaries of efficiency. The future of AI in manufacturing and logistics points toward fully automated, adaptive, and sustainable systems. Factories will increasingly rely on AI to design, monitor, and adjust production in real time, creating environments that learn and improve continuously. Supply chains will become more transparent and resilient, using AI to anticipate disruptions and respond instantly. Autonomous vehicles, advanced robotics, and edge computing will blend into seamless networks, reducing human effort while expanding human oversight and strategy. Sustainability will remain a guiding principle, with AI ensuring operations meet environmental as well as economic goals. While challenges around cost, integration, and workforce adaptation remain, the trajectory is clear. AI will become the central nervous system of global production and distribution. The result will be industries that are not only more efficient but also more intelligent, adaptive, and resilient. AI in manufacturing and logistics tells a story of transformation across production floors and global supply chains. From predictive maintenance and digital twins to warehouse automation and autonomous vehicles, intelligent systems now underpin efficiency, quality, and resilience. These tools reduce costs, improve safety, and make businesses more adaptable to change, while also addressing sustainability challenges that define modern industry. Yet adoption is not without barriers, as companies must invest in technology, integrate with legacy systems, and support workers in adapting to new roles. The balance between innovation and inclusion will determine success. For learners, the key insight is that AI is not a distant possibility, but an active force shaping how goods are made and delivered today. Its continued evolution promises a future where manufacturing and logistics become smarter, greener, and more resilient than ever before. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.